lecture. Yes, I picked some questions that I asked in quiz and some more that I asked in homework, last one. So I solved them and I will explain you. Actually, we did it in the class, but I will solve here as well. First of all, let me to share something. Okay. Let me to say again what I'm going to ask in the exam first. In final exam, I'm going to ask from first midterm about 30 points, and one of them will be true, false, or fill in blanks questions. And the other one will be I will ask, let's say, the one that I'm going to ask. So let's say this will be 10 points.
True about false question or
Sorry? Okay. So in the other questions, okay. Okay, can you mute your voice? I don't want to do it one by one. Okay. After first midterm, after midterm. You will have questions from memory management, fixed and dynamic compaction. And from the linked list, which I'm going to give you the examples. So let me to start. Okay, the others, can you see the screen?
Yes, yes.
Okay, thank you. Okay. I created a PDF file that I solved the questions, but they're not appearing so well. So after I made the lecture, I will send you the better view. I will snap them again. Let me to share that one. One second. I am going to mute everyone. You can just please text me, okay? It is better. Because when someone is connecting to lecture, they are not muting. Oh, it is so bright, I think. Okay. Sorry about that. Any version that's new. I think I can't make it darker here. Anyway, I will send you the better version, but I think the numbers is appeared in the quiz. I asked the shortest job first. So I'm going to give you the solution here. I will send it. So because of I'm not going to ask in the exam, I'm just skipping this one. I will not ask the shortest job first, but the answer is there. Actually, I would not say to you that I will not ask, but okay, I said that I will ask round robin. So I am skipping this one. You can check it. Oh, it is so bad. Sorry about that. Okay, I'm going to read it. Just 1 second. Okay, it is asking in the quiz. I asked that if the size of the memory is 20 megabytes and we have 5 partitions, which 4 megabytes each. Okay, so, and I said that it is fixed. When I said fixed, it means that it is a fixed partition. So you can understand that how you can solve it. So it is saying illustrate or draw the memory. If the processes are coming like 2 megabytes, 2 megabytes, 3 megabytes, 2 megabytes, and 3 megabytes. Okay, so they are coming with this order. So when they are fixed, first of all, and I set 5 partitions, 4 megabytes for each. So for fixed partition, you have to create 4 partitions, 5 partitions, which 4 megabytes each. Okay, so you have to divide it to 5, and each of them will be 4 megabytes, like this one, this one, this one, and this one. So I divided to 5. Then you have to put the processes. The first one is 2 megabytes. So I put 2 megabytes of process, and I have remaining 2 megabytes here, just empty space. And then another 2 megabytes come. I put it to the second partition. So again, 2 megabytes of empty space remaining. Then I put 3 megabytes. So 1 megabyte of empty space remains, 2 megabyte again, and 3 megabytes. So I located them like this. So my internal fragmentation is the each remaining space. Okay, here it is 2 megabytes. Here it is 2 megabytes. Here it is 1 megabyte. Okay, because I have 4 megabyte of partition and 3 megabyte of process came. Then 1 megabyte remains. So you can calculate the internal fragmentation like that. You don't need to. How can I say? To add them. Okay, you have to write them separately because internal fragmentation is the fragmentation of each partition. Okay. Can you hear my voice? Okay, so put it. Okay, the guy who told me he or she is not hearing. Huh. Okay. Now it is okay, I think. So you can solve this kind of problem. I will ask one question like that. For the external fragmentation in fixed partition, it is the addition of all fragmented parts. Okay, so external fragmentation is 2 plus 2 plus 1 plus 2 plus 1. So it will be 8 megabytes. Okay. So in part B, it is saying what will happen if the last process size is changed from 3 megabytes to 4 megabytes. So if the last process size, this one is, it was 3 megabytes. Okay. If it is not 3 and 4 megabytes is coming, so all process will put here, so it will fit there. Okay. So the answer is it fits. It still fits in the partition inside the memory. Okay, here. But if the question was instead of 3 megabytes, 5 megabytes of process comes, let me to erase all of them, and instead of 4, let's say 5 megabytes of process try to come inside. In this case, because of the partition size is smaller than the process size, it will not fit. So that process will not be executed. So you have to answer like that. So just remind this. Yes, Isaac, I didn't see, I just see your message, but I think we are thinking the same. Okay. So let me to continue. Sorry about this. Anyway, I will. Okay, in the same scenario, if the partition type is dynamic. So it is saying, it is writing here, I can make it bigger. Okay, same scenario. If I will be able to modify it. Same scenario, but this time dynamic. So what was it? I think the memories are coming 2 and 2 and 3 and 2 and 3. Okay. So Isaac, I just explained the 5 megabyte. So the operating partition. Okay. Isaac asked, do we need to mention the operating system partition or not? Actually, in this question, it is very clear that it is dynamic or fixed. But if I don't say you the partition type, and I am just waiting from you to understand and write, that time you have to say me. But here, if I understand you correctly, you don't need to mention it. So in this case, this scenario is same, but this time it is dynamic partition. So in dynamic partition, we were just using creating partitions according to the process size. So when think about that, this is just empty. I mean, in memory, nothing. We have no partition, nothing. So when 2 megabyte of process comes, system will allocate a partition in 2 megabytes. Okay, then other 2 comes, so system will allocate another 2 megabytes of partition. Then 3 megabyte comes. This time it will allocate 3 megabytes, then 2 megabytes, then 3 megabytes. Okay. And because of our memory size is normally 20 megabytes, we have remaining 8 megabytes. I think, Isaac, you are asking this, if I understand correctly. Okay, yes, I may ask the remaining how many megabytes of space we have remaining. So you can easily just subtract from 20 here. Okay, I have 2, 2, 3, 2, 3. So totally 4, 7, 9, 12. 12 megabytes of used space by processors, used memory, and 8 megabytes is remaining. Okay, so this is how you can draw and just answer part C. Here, the internal fragmentation is 0 because we are just creating the partitions according to the process sizes. External fragmentation is also 0. Maybe some of you confused about the external fragmentation because we have here some empty space. But let me to give you an extra explanation. Okay. External fragmentation occurs when the free parts of or empty parts of memory are not contiguous. Let me to remind you what is contiguous. Contiguous means if the empty parts and the processes are just coming one after the other. How can I say? Let me to draw. 1 second. Contiguous is something like that. Think about that. This is the memory. If let's say this is a process. This is a process. Okay. And this is another process. Okay. And this is another process. Think about that when the last 2 processes finished execution. Normally, how can I say? One process was here, okay, and the other one was here. But when they removed, this space is contiguous. It means the empty spaces are coming one after the other. So the external fragmentation occurs when the free parts of memory are not contiguous, like this one. think about, we have some empty space here. So this is empty part of memory. This is empty part of memory, but they are not coming one after the other. So this is called not contiguous, okay, or non-contiguous. Okay, let me to continue. By the way, I have to erase this as well. Okay. Yes. So in part D, it is saying, explain what will happen if the last process size will change to 3 to 4 megabytes. Okay, it will fit, because if it is 3 to 4, it will be 4 megabytes here, and this will be 7 megabytes. But even the coming process is bigger, it will still fit, okay? Until a kind of, for example, 12 megabytes of process comes, these coming processes can fit, because there's a contiguous space that memory can use all of them. Okay, another question, in question 3 that I asked in the quiz, estimate the CPU utilization. So the process size is 2 megabytes, memory size is 4 megabytes, input output time is 50%. What does this mean? Half of the execution time, I mean the burst time, will wasted by input output. Okay, so process size is 2 megabytes, memory size is 4 megabytes. So CPU utilization can be calculated by using 1 minus P over N. So P is, when you say input output time, it is P, which if it is 50%, you have to say 0.5. If it is 70%, you have to say 0.7. Okay, so and N is the division of the memory size to process size. So this is roughly can calculate how many process we can fit into the memory. So if my memory size is 4 megabytes and process is 2 megabytes, that I mean the types of process that are coming is roughly, if they are 2 megabytes, so we have to say 4 over 2. So it will be 2. Okay, so the only thing is I have to put these two values into formula 2 and 0.5. So 1 minus 0.5 square. So 0.5 is, the square is 0.25. So 1 minus 0.25 is 0.75, and it is 75%. Okay. Yes. No, calculator is not allowed. Sorry about that. But really, I was trying to say in the quiz like that. If you put me this one, okay, still I will accept, but is it hard to calculate 0.5 multiplied by 0.5? It is, okay, 5 multiplied by 5 is 25. Okay, so we have decimal point, so we are multiplying 0.5. So you have to go to left. I mean, I'm trying to say this. So if you multiply 2 decimal points, 2 numbers with decimal points, so you have to say, when you calculate that like that, you have to say how many digits I have to go left to find my number. So like this, you can calculate. Sorry.
Himself to the governing authorities, but there is no authority except that which God has established. We should submit or we should be subject to or authorities.